All right, let's get started. Good morning, everybody, and welcome to day 3 of Build. My name is Akshay Agrawal, and I'm a senior program manager in the Windows graphics team. I've been on this team for about 5 years now, and I've met many of you here in the audience. I know many of you because I worked on Windows 7 on displays and projectors, how to improve the experience there, and it's been a great experience. Since Windows 7, I've kind of moved on, and I'm focusing a little bit more on the broader aspects of the WDDM driver model and how it works on Windows, the different versions of Windows, etc. And that's what my focus has been for Windows 8, and that's what I'm here to talk to you about today. So this is the agenda for today. I'm going to start off just talking about what exactly do I mean when I say graphics on the server. It's a very broad spectrum of scenarios, and I'm going to focus on some parts of it, and so I'm going to lay out exactly what I'm going to focus on. Next, I'm going to talk about the graphics driver model on Windows, and what are some of the scenarios it supports that are specific to servers. We've heard a lot about the client scenarios and how the entire Metro user experience is based on the graphics hardware acceleration. And I kind of want to map it out, that how does this map to the server world where the requirements and the hardware is a little bit different than what we see in the client. And I'm going to conclude by kind of wrapping it all up and showing a little mapping that based on the scenario that is most important to you, what part of WDDM is best suited for your requirements. During the session, I'm also going to talk about and really highlight the Metro style experience and the applications we saw, and how does it depend on the WDDM driver model. And also I'm going to highlight how the graphics driver model has key features for the users. You know, we've heard about that for the last couple of days, but also for the administrators who are managing these servers. There's a lot of features there that are for those part of our customers. So let's jump right in. What do I mean by graphics on server, right? When I started looking into this area about 2.5 years ago, it was really interesting because what I quickly found is that graphics on server is in a slightly different position than client. It actually pushes the boundaries of the graphics subsystem in a much bigger way than it does on client. And what I mean by this is there's two spectrums of scenarios. So on one end, you have a scenario where an administrator, an IT manager, is logging into the Windows desktop console, and this might be either a physical server or a virtualized server, and he's logging in for managing the server. He's logging in to maybe configure it, maybe launch some applications, or something like that. And his requirements are very simple. He wants a good user experience, but at the same time, he wants no compromise on the reliability and stability of the system. So the requirements are very simple, and we don't really expect him to be launching some complex DirectX games or maybe watching 3D video. I don't think that that's really happening on the server. And so this is really pushing the spectrum of the graphics driver model, I would consider on the lower end. The graphics drivers, the graphics hardware, and the drivers we have today are capable of a lot more than what these scenarios require. So this is pushing it on the low end. And then if you go to the other end, you have scenarios where you have like maybe a server farm, and you're using those servers and using the GPUs on those servers for general purpose compute scenarios. So maybe it's a video encode, decode, maybe it's animation. And here, really the requirements are to really get utilize the maximum horsepower of that GPU and utilize the maximum power of the driver model. So as you can see, this is a very, very broad spectrum. And what really this means is that the Windows driver model has to be able to scale across the spectrum of scenarios and the spectrum of requirements without any compromises in the stability, reliability. Those are just like the tenets of any server system. So that's what I've been really focusing on for Windows 8, and that's what I'm going to talk to you about. So what is the graphics driver model on Windows? So many of you are familiar with Windows Server 2008 and 2008 R2. You might be shipping systems with that or working on drivers or hardware on that. And Windows Server 2008 supports two driver models. On one side, you have the driver model introduced in Windows 2000 or XP, and we call it the XDDM. so it's the XP display driver model. And on the other side, you have the Windows display driver model introduced in Vista, which we call as WDDM. So there's these two graphics driver models that are possible on Windows Server 2008 and R2. Now, what this means is this is great, but it also comes with certain challenges. If you're a customer, now you have these two different driver models, and you have to understand the ramifications, the benefits, the pros and cons of each one of them, and take a decision which one you want to use. If you're a system builder, again, you have to be able to design a system using either of these two pieces of hardware and work with the IHVs, get the drivers, and so it's added complexity to the system. And if you think about the application developers, that's where it becomes very challenging, because now when they write an application, they have to detect at runtime which driver model is in play, which APIs are going to be available to them. And what this can mean is that sometimes they might actually have two different code paths in their application. And this makes it difficult for the application developers. And really what the promise we are making in Windows 8 is that there is one set of APIs that always works on Windows 8. So that is what the promise we've made over the last couple of days, and that is what we've been working on. And last but not the least, this is super challenging for Microsoft. This is challenging for us to maintain two different graphics driver models on one operating system. And the work that goes into maintaining the stability, the reliability, working with all the IHVs for the drivers. And so as an ecosystem, as all of us here in this room, this is a challenge. And so as we started working on Windows 8, we started moving towards the single driver model for all of Windows. For all versions of Windows, now we're going to have a single graphics driver model. And Amit talked a little bit about this in his talk yesterday, that we have now removed the ability to run a XDDM driver on Windows 8. And so Windows has one driver model, and that is WDDM. And what we found is that as we started analyzing the server scenarios, we found that there are various opportunities and various to optimize this driver model for server-specific scenarios. WDDM has been designed really for the client scenario, for a highly interactive and visually rich experience. And as we analyzed it more, we found that on servers, there are certain different scenarios. And so for Windows 8, we have really optimized WDDM to focus on these server scenarios. And that's what I'm going to talk about today. I'm going to talk about the various ways in which we have evolved and optimized WDDM for servers. So what does this single graphics driver model offer us? Right? What I've done is, many of you are already familiar with WDDM, and many of you might not be. So what I've done is I've taken the features and I've kind of bucketed them into three groups. The entire feature list of WDDM is quite large, and you can all read it up. But I just wanted to highlight on a few key features. So if you look at the first bucket, we've all been seeing the Metro style experience and the Metro style applications, and that experience is really dependent on WDDM. Mike Angelo spoke about how it's all hardware accelerated, and it all depends on WDDM. And a lot of the DirectX APIs, like Direct2D, DirectWrite, D3D, a lot of these are really tied to WDDM. They don't exist on XDDM. So really the goal is to bring this rich experience even to the server world. Now, that doesn't really mean that every server has to use this, UI. There's various options. There's various ways you can configure your server, and you can scale the UI one way or the other. So, but the main goal is, as we interacted with our customers, we found that they wanted the consistency. They get Windows 8 client, they start using the user interface, and then the difference in the user interface becomes challenging. And so we want to provide this rich experience for all the users. At the same time, what this means is, by bringing the Metro style experience, it also means that we're bringing DirectX capabilities. So again, going back to the application developers, they have the promise that on any Windows 8 system, the DirectX APIs will be available to them. And I'm going to talk to you about how we make that possible. Next is availability. Now, this is a big word. I was there for Mike Neal and Bill Lang's talk yesterday, and they had a bunch of demos, and I was amazed to see how big a word availability is. Uptime for the server is really key. And I just saw the demo after demo, like, hey, you're moving a storage, you're moving a network device, etc. And WDDM has been designed from day one with reliability and stability in mind. And we really wanted to bring that to the server, to our server customers, to take advantage of that stability that it brings to the system. And so some of the features you're already familiar with since Vista, when we introduced this, like rebootless driver upgrade, the timeout detection and recovery mechanism, where Windows can detect if a graphics card is not responsive, and it can reset it on the fly without ever rebooting the machine. And in Windows 8, we've also added some more features, like the preemption and better error logging for debugging the drivers. So there's a bunch of these stability-related features that WDDM brings that we really want to bring to our server customers. The next is innovation. Now, on server world, you kind of stop and wonder, like, really, how much of the innovation do I care for? But remember, the innovation is not just in client-faced scenarios. It's not just stereoscopic 3D or any of the other client-focused video playback kind of scenarios. There's also things like UEFI GOP, which is the graphical output protocol. And in WDDM 1.2, the driver model for Windows 8, we've added support for this. And so the GOP has already been there in the market for a few years, but we're bringing it to WDDM now. And so there are a lot of innovations that we're bringing, and we would really like to bring them to our server customers as well. So at a very high level, these are some of the highlights of this single driver model, and I'm going to go into a little bit more detail. So again, I'd like to just iterate before I move on to the scenarios, is that WDDM is the only graphics driver model on Windows client and server. So going back to the key scenarios I spoke about at the start of my talk, what I'm going to do is I'm going to talk about some of these scenarios and really talk about which part of WDDM is best suited for these scenarios. So the first one was, again, the scenario where the administrator is logging into the desktop, whether it's a physical or a virtualized desktop for management purposes. And really, you have a couple of options here. You can, if it's a physical or a virtualized server, you can really get a driver by working with your IHV or your ISV vendor. And this would be a WDDM driver. And I'm going to talk about next how you can create a WDDM driver for your XDDM hardware. Because we really understand that a lot of the servers today are shipping with XDDM hardware, and we want to bring all of those customers onto Windows 8. And so we're going to show you how you can build a WDDM driver for that XDDM hardware. At the same time, we also realize that there are some scenarios where the requirements are fairly basic. And to keep the system complexity simple, you might want to just depend on a driver provided by Microsoft. So Microsoft is also providing a driver within Windows, which will work on XDDM hardware. Now, of course, this will have a set of functionality, and if you want to go beyond that, then definitely you have to work with one of your vendors. So let's talk about how you can write a WDDM driver for XDDM hardware. So if you think about WDDM, many of you are familiar with it. You've been writing drivers for it on Windows Vista and Windows 7. And if you're currently shipping a system, like a server system with a WDDM driver, then there is no change for you as part of Windows 8. You continue writing your WDDM drivers. Amit spoke yesterday about the incremental changes we've made to WDDM in Windows 8. And so some of those features are optional, some of those features are mandatory. And so you just have to make an incremental change to your driver, and you're good to go, even on the server. One of the small changes we are making is the support for desktop modes that are less than 32 bits. And so WDDM will no longer support desktop resolutions of less than 32 bits per pixel. Now, the reason we are doing this is, as you know, we're providing this rich experience to the Windows customers. And at a lower color depth, the experience is just not as rich. And what we saw is that as we're doing the animation or the alpha blending, the experience is not as good, and the user might see banding or other visual artifacts. And so what we're doing is we're focusing on 32 bits color for Windows 8. Now, I talked to you about your XDDM hardware. So what we're doing in Windows 8 is we are extending the WDDM drivers, and we're creating a new type of WDDM driver that you can write, and we call it a display-only driver. So as the name suggests, such a driver is only responsible for display scan-out functionality. It is not responsible for any hardware-accelerated 2D or 3D operations. And so what this does is it literally becomes like a frame buffer driver. And so all the XDDM hardware that is already out there, you can write a display-only driver for that, targeted towards that hardware. And what happens is that Windows handles all the 2D and 3D rendering on behalf of the driver. And it does so by using an in-box software rasterizer. So the driver is not responsible for any of those operations. And so what that means is that the entire MetroStyle experience, the entire MetroStyle applications, the DirectX 11 APIs are all made available on this hardware, and it is all handled by Windows. There's not any work for any of the vendors. Now, we do understand that the hardware on these systems is actually, it's capable hardware, and it has capabilities for hardware acceleration, like screen-to-screen moves or dirty regions, etc., or hardware mouse pointer, and we've made sure that you can still accelerate those operations. Now, because this is an extension to WDDM, it comes with the same features that WDDM offers. So the driver install experience is the same, the rebootless driver upgrade is the same, the timeout detection and recovery is the same. You can put your driver on Windows Update. So you get all of that for free. Multi-adapter, multi-monitor, all of that comes with this type of driver. So what I'd like to do now is kind of dive in one level deeper and just give you a slightly better understanding of how the display-only driver works. So what I've done is I've kind of split the responsibilities between Windows and the driver into two sections. On the left is what Windows will do, and on the right is what the driver is responsible for. So as I mentioned earlier, the install experience and the driver initialization experience is exactly the same as WDDM. The system boots, the driver, if it's not installed, it gets installed. The driver the call is made to start the driver. And because this driver is only responsible for display capabilities, Windows queries the driver to say, hey, tell me how many monitors are connected, just the way we do today in WDDM. And so it can support 1, 2, 3, number of monitors that it needs to. So the task of the driver is just simple: find out the number of monitors connected, report back to Windows, and typically the monitors have the EDID, which is a blob of data that describes the capabilities of the monitor, and it just passes it back to Windows. So we can set the correct resolution and the correct timings on the display. From there, Windows is responsible for doing all the 2D and 3D operations. And so it'll configure the desktop, set up, if it's multiple monitors, set it up in extended mode, and start drawing the desktop on behalf of the driver. So what it does is it uses the software rasterizer, and then as each frame is composed, it puts it into system memory. Now, with each frame that is put into system memory, we also provide a rich set of metadata. And the purpose of this metadata is really to give the driver opportunities to optimize the driver. And this metadata is in the form of dirty regions. So assume on frame 0 versus frame 1, just one block of maybe 10 by 10 pixels has changed. So we actually tell the driver that, hey, this block located at this location has changed. And the driver can optimize and just send that part of the data out for optimization. And the same with window moves. So assume the user is dragging a window. It's the same content, it's just being dragged along the screen. So again, that's metadata that we provide to the driver. And I also mentioned the mouse pointer. So full hardware accelerated mouse cursor, just the way it's supported on WDDM, is made available for this driver. And so what we do is we pass all that information to the driver, and now it's up to the driver to compose this image, to take all this data, compose the frame, and now it has options. It can do any kind of optimization it wants. And then it has the option of either scanning out to a physically connected monitor, so maybe that's over HDMI, DisplayPort, VGA, whatever the supported connector types in WDDM. Or if it's a virtualized hardware, you have the ability to scan it out in whatever way you do today already. So you can reuse some of your existing code that you might have for the virtualized drivers. So as you can see, this type of driver supports both the hardware and the virtualized XDDM hardware. And there's a lot of flexibility for the driver to optimize this scenario. So that covers the driver provided by an IHV or an ISV for the scenario. As I mentioned earlier, there are certain scenarios where the requirements are very simple, and it's possible to just use a very basic driver. So in the past, this has really been the VGA driver. You've all been using the VGA.sys and VGA.pnp drivers, which are really the default drivers in Windows. What we're doing with Windows 8 is we're introducing a basic display driver. Windows will have this driver always by default, and it really replaces the VGA PNP and the VGA save drivers. The reason we're doing that is because, as I mentioned earlier, we are removing XDDM support. And so that rule applies to us equally as it applies to everybody else. And so we ourselves had to go look at our driver and say, okay, we need to change this, update this driver. And so really what it is it's a display-only driver. The exact model that I explained to you a minute ago, it is the first driver based on that driver type. And so we are using the exact same software rasterizer. We're getting the exact same metadata. And obviously, our ability to do optimizations is a little bit limited because we are working on basically the firmware. We are basically using the BIOS or the UEFI GOP for the scan out. We don't have access to the hardware acceleration. So you're in a much better position to use your XDDM hardware and get better performance. But this is really our VGA replacement. And again, it obviously brings the Metro style experience to the customer. And what's been really funny is that as we've been working on Windows 8 and developing it, a lot of people, they run their system for maybe a couple of days. They don't even realize that they don't have a full an IHV provided WDDM driver. The performance we've been getting with this driver has been pretty good. The experience visually is pretty good, and it's a really good alternative. So really, the goal is to really closely analyze what your requirements are. What does your customer really want to do? And then decide what driver is best suited for your purposes. And so as I spoke earlier, this driver model, it supports all the DirectX 11 APIs. And that's what you've been hearing from us over the past couple of days, and you'll hear more about it today, that application developers can depend on the DirectX 11 APIs to always be available on Windows. And so obviously the APIs scale based on the hardware on the system. So if it's and so that's what's called the feature level capabilities of DirectX 11. And Dan McLachlan will talk a little bit more about it tomorrow. But from an application developer's point of view, if he takes a dependency on DirectX 11 or D2D or DWrite, he knows that it's always going to work. And we also have support for DDraw and DXVA for backward compatibility. The one difference another difference this has compared to the VGA driver, as I said, is the support for UEFI GOP. We've been talking a little bit about UEFI. We saw a couple of demos of the really fast boot. And some of those are made possible by UEFI and the UEFI GOP, which is the graphical output protocol. And it's not really a matter that UEFI is better than BIOS or better than all the work that's gone into BIOS. It's a newer technology. And they've been able to start from scratch and really optimize it right from day one. And so we've added support for that. And so what that means now is that you can ship a system with no BIOS support at all, right? Currently, I think a lot of you are doing the CSM and emulating the BIOS and etc. You don't need to do that anymore. So this really helps remove some of the complexity on server systems. So what the basic display driver does, it also helps expand the scenarios that we can imagine, right? Because it's a WDDM driver, it comes with the same abilities of multi-adapter capabilities that WDDM has to offer. So now you can imagine a server system or any system for that matter, that has 2 graphic cards on it. And these can be from 2 different vendors, that's fine. One of them has to be the post device, and this is same as it is today. There's no difference there. By default, the Windows Server does not have any in-box graphics drivers. You typically have to go and get the graphics driver and install it. So what that means is, by default, the basic display driver will run on the post device. And this is exactly the same as VGA. VGA used to run on the post device. But the difference is, now while this basic display driver is running on one adapter, the admin can go and install a vendor-provided WDDM driver on the second adapter. And now, so you have multi-adapter configuration up and running. And for example, the first the first adapter might be a simple, maybe it's the XDDM hardware that you've been shipping. And you're just running the basic display driver on it, you're just logging in, doing a little bit of configuration, you're done. The second one could be an adapter focused on high-performance computing. And you can run both of these in parallel now, and the second adapter might never get, if you don't connect a monitor to it, it'll never get interrupted for display scan-out responsibilities. So it gives you a lot of flexibility now to configure your system in a way that is best suited for your requirements. But as an IT admin, I might not be happy yet. You know, I'm like, my first adapter, that's a pretty good adapter, and I really want scenarios supported by the IHV on that one. So I go ahead and I install the IHV provider or the vendor-provided driver on that adapter as well. Great, now I have multi-mon, everything is working fine. The beauty of it is, he did all of this without ever rebooting the server, right? And that's what I talked about earlier about the availability. Because it's WDDM, you have rebootless driver upgrade. So you can upgrade from the basic display driver to the IHV driver. You can disable the driver, you'll go back to the basic display driver. This is all just seamless, you know, it just boom. And again, Amit spoke yesterday about the seamless transitions. You know, so we've eliminated a lot of the screen flashing and other stuff that goes on during these transitions. So this is some of the new scenarios that we enabled by making the default driver as WDDM. So that kind of wraps up that scenario. You know, I was going through the scenarios. That really wraps up this end of the spectrum of scenarios. The other end of the spectrum is high-performance computing, right? And this is possible today. It's not rocket science. We're not bringing a whole new set of things here. But what we saw is there are certain challenges. There are certain roadblocks that all of you today have to jump over to make high-performance computing a seamless experience. And what this does is it really adds complexity to the system. And again, complexity is not a good word on servers or on any system for that matter. And so what we did is we analyzed it and we saw, again, some key optimizations that we can do to the driver model, to DirectX, to make high-performance computing much easier. So let's talk about that now. First up, again, just to categorize the scenario, it's high-performance computing. You're using the powers of the GPU, the horsepower of the GPU, for from general-purpose computational tasks like animation farms or video encode, decode, etc. And again, you have a couple of options here. Really, for this scenario, using the IHV or vendor-provided driver is the #1 option because they are in the best position to utilize the power of that GPU. They understand the hardware specs, they can optimize their driver and get the best performance out of it. But again, as I keep mentioning, we have the promise to the developer that the DirectX 11 APIs are always available to you. And for that, we're providing a default driver for computational purposes as well. And so again, this ships within Windows, and the application developers can use it. We have optimized it a lot. It's going to use the software rasterizer, and I'm going to talk a little bit about that as well. So going back to this, I showed you this, how we've extended WDDM to support display-only drivers. What we did is we extended it further, and we added a render-only driver. And so as the name suggests, such a driver is only responsible for hardware-accelerated 2D and 3D operations. It is not responsible for any display scan-out functionality. And so what that means is you cannot connect a monitor to it. If you assign a task to it, a long computational task, you'll never be interrupted to go and display on the screen or scan out on the screen. And you can just use that GPU for a long time. There's no VSync TDR or anything. It's for the application developers to share, especially with the GPU preemption feature. You can even have a couple of applications just going at this GPU and utilizing it to the maximum. So let me talk a little bit more about that. As I said, it only supports the render capabilities. And again, the advantage here is the multi-adapter support it brings with it, right? Again, you can have the system configured to have the basic display driver or a default driver running on one side as a simple frame buffer, and all the display scan out, whatever display might be, will happen on that adapter, and Windows will take care of the rendering. And on the other side, you have this GPU that is purely available to the application developer for computational purposes. So it's a very powerful type of driver available to the user. Now the good part is, how do you write such a driver? If you're currently already shipping a WDDM driver on Windows Vista or Windows 7, it is super easy to convert it into a render-only driver. The driver interfaces are exactly a subset of what you see today on WDDM. Literally what we did is, if this is the list of interfaces, we put a line in the middle, and the top ones are for render, lower ones are for display, boom, done. And literally within a day or so, you can take your existing WDDM driver and convert it to be a render-only driver. And what we have, this talk that I'm doing here is kind of a two-parter. I'm talking about a lot of these features, and I'm really giving you an understanding of what we have to offer. And then we have a chalk talk later on today. It's session number 220, and it's at 2:30 p.m. today. And I have Roger Coote here. He's a senior developer on our Windows team, and him and I are going to be in a chalk talk. And really, if you have more questions on this, on any of these driver models, or how to write a driver for that, we have an entire hour where we are happy to go through a little bit more details on the interfaces and what you can do, what are the optimizations you can do, and so we have an entire hour for that. So please join us for that. Next, I spoke about this basic render driver. And so this is, again, the software rasterizer that is included in Windows. This was actually introduced in Windows 7. A lot of you might know about it as Warp. And what we've done is that we've made it into a render-only driver now that we have this driver type. And what this lets us do is that for all the display-only drivers, so whether it's coming from an IHV or it's the basic one, this render-only driver is the one doing the rendering on behalf of that driver, on behalf of the display-only driver. And what we've done compared to Windows 7, we looked at this software rasterizer, and now we focused it on the key scenarios for Windows 8. So the key scenarios are rendering the desktop, showing the metro style experience and the applications, and how all of those use the various DirectX technologies like D3D, D2D, D-Write. So we've done a lot of optimization there. We've done a lot of optimization for the desktop window manager, which is managing all the windows for scan out. And we have a whole team of people just sitting there and optimizing this code. And what we found actually is that we're at a point now where in some cases, it actually performs better than a GPU, right? And this is not broadly across the case, but on some cases, actually outperforming some GPUs. And so really, the goal of this, having this in the box, is again for the developer promise. The DirectX 11 APIs are always supported. And so with this driver, we support all of these features that are available on DirectX 11. And it's also very easy for the application developer to know and understand that their application is currently running on this driver versus an IHV one, because as they enumerate the DirectX devices, it can easily identify itself by this flag. So the application developer does have the opportunity to know about that. So that covers some of the changes to the driver model and what we've done there. Next is headless system. This is an important word again for server scenarios, because again, going back to the server farm, there are many cases where the goal is just to assign a computational task to a server, and there might be n number of servers there. The administrator is never really going to log in to that server. All he cares about is, here's a task, complete the task, and let me know. And this could be, and so what that really means is that there is no need for any graphics hardware, right? There's really no need. You're never going to connect a display device to it, and the only access is going to be through a remote session or a remote access driver. But again, when we went back and looked at Windows currently, we found that Windows requires some basic display functionality today. And this is in the form of an int10 call, which is a BIOS interrupt to reset the BIOS to graphics mode. And the reason we require this today is in case Windows experiences a critical error, what we have to do is we have to bug check the system, or the blue screen of death, as it's called. And for that operation, we need to be able to reset the BIOS and display the screen. And the reason we do that is so that at least we feel that the user might have, in case he has a monitor connected, he can see what went wrong, why is his system rebooting, at least they have a chance of seeing that. But what this does is, for headless scenarios, a lot of times there is no graphics hardware. And what the system builders and what many of you have had to do is you have to write this stub driver or emulate the int10 call to just tell Windows that yes, I support the int10 call, but in reality you don't. And this is again added complexity, right? We really don't want to place this burden on our partners. And so in Windows 8, we've removed this requirement. Windows 8 supports true headless systems. You do not need any graphics capabilities, no need for BIOS, no need for anything. You can just run it without any GPU at all, or you can run it, maybe you can just stick a render-only GPU and utilize the horsepower of the GPU without having any display scan-out functionality whatsoever. So this is a small optimization we are doing for the high-performance computing scenarios. The next one is DirectX. So again, I spoke about how DirectX is the API that our developers are going to use. It is a commonly used API for general purpose compute, rendering, animation, etc. There are other options. DirectX is commonly used. Again, in this scenario, really the goal is not for the administrator to log in. It's really the goal is for this to run as a background process, right? So you assign a task to the server, it's running in the background, there is no interaction with the server. Now, DirectX has been around for many years, and the way it has been designed, it's really right at the start, it was designed for this hardware accelerated, direct access to the GPU, and it's super performant. But the focus has always been on a user interactive model, right? You're writing a DX game. You're writing something where you expect a user to be sitting in front of the machine and utilizing and interacting with the system. And so the DirectX APIs have really been tuned to work with the user present. And so in Windows terms, the way Windows operates is that by default, when the machine boots up, we start off session 0. And session 0 is where all the services, all the background processes are running. And when a user physically logs into the system, or even through a remote session, they're really going into session 1. And that is where we really made available all the DirectX APIs. But really in this scenario, there might not be any user logged in at all. And so what we've done is we've enabled all the DirectX APIs to work in session 0. And so there's no need for any user to log in. You can just create an application that uses the DirectX APIs. It'll either use the hardware, the WDDM hardware, or it'll use the software rasterizer, whatever it might be, and your application will just run. There's no need to log in any user. Now, of course, there are 2 exceptions. There's a couple of APIs that are really focused on display management within DX, and obviously, since there's no display connected here, those APIs will not work. Last, I'm going to talk about the accelerated massive parallelism C++ APIs, or we also call them C++ AMP, AMP. And with Windows, you always get a rich set of APIs and tools, etc. And this is really a call out to my colleague Daniel Moth. He has a talk on this API set. And at a very high level, what this does is it provides developers who have C++ knowledge. That's their skill set. It gives them the opportunity to target the CPU or the GPU right from within C++. They don't have to learn a new skill set to target the GPU. They can just reuse their C++ knowledge. And what this does is it actually builds on top of DirectX. And so it just it brings all the advantages of DirectX, which are hardware diversity. So no matter what hardware is on the system, if you're using this API, you'll get the benefit of the GPU. And so that obviously means the performance, the productivity, because you can use your same skills, and portability across. And so it's the same binary that's going to work across these different systems. And so Daniel Moth has a talk on this API, and I have a reference to it later on. I don't remember the number off the top of my head. So that kind of covers all the optimizations we have done for high-performance computing scenarios. The last scenario I want to talk about is remote desktop access and collaborating. So this is the scenario where I'm logged in, I have a desktop running, and I want to share it with someone, right? So this scenario, there are various ways of completing this scenario today. Typically, we've seen people are using mirror drivers or screen scrapers, and they're just providing the access to the data on the screen. Now, this itself has a few challenges, right? As we are moving ahead, more and more of the interface and the metro-style applications, more and more of the applications are using DirectX APIs. And a mirror driver, many of you might know or might not know, but a mirror driver is basically an XDDM driver. And so what that does is, literally for XDDM, a DirectX application is just a bitmap, and you just end up doing bitmap remoting in that case. And bitmap remoting, it requires a lot of optimization. And so what happens is that the application developer, he has to put in a lot of effort to figure out what are the dirty regions or what other optimization opportunities are there, and it spends a lot of resources on that. And what happens is that as new APIs come out, maybe DirectX, now Direct2D, Direct3D, you have WPF, HTML5, you have to kind of constantly be updating your software to react to these different APIs. So in Windows 8, we really wanted to bring this metro-style experience and these DX applications to this scenario. And so what we're doing is today we're introducing a new API called the Desktop Duplication API, and that's what I'm going to talk about now. So the Desktop Duplication API is a new DXGI-based API. DXGI is already in Windows 7. So we just added to that API set, and it's really designed from day one for remotely accessing your desktop or remotely sharing your desktop out with someone. And from day one, this has been designed keeping the metro-style experience, the metro-style applications in mind, and making sure that they work really well. We've also designed it to work with full-screen DX applications, right? And the way it works is it's actually a bitmap-based duplication scheme, right? And so what that means is no matter what the application is using, what API it's using, this API is just going to work. But I just called out some challenges with a bitmap-based remoting. And so what we are doing is, along with this bitmap, we are actually providing all the data that is actually complex to generate yourself for the application developer, which is the dirty regions, the screen-to-screen moves, the hardware mouse pointer. And so Windows has this information with it. And so what we are doing is we are providing that information to the application. We're just bundling it up and providing it. And so that removes that whole complexity out of the scheme. And the API is just going to work. No matter what application is launched on the screen, the API is just going to work. Now, one difference in this is that the duplication is along the monitor boundaries. So unlike the mirror drivers where you can etch out just one particular part of the screen or one window, this is along the monitor boundaries. And so what I'm going to do now is, again, dig in just a little bit into this API. And again, it's kind of the same model I had earlier. On the left side is what Windows is going to do. On the right side, what the application needs to do. Again, note that this is not a driver. This is an application. It's an API being used. And so, again, the application has the choice. It can enumerate all the monitors connected on the system, and it can decide which one of the monitors it wants to duplicate. It indicates that to Windows. And Windows, again, does something similar like it did for the display-only driver. It creates a copy on the application's behalf. It puts each rendered frame on behalf of the application, along with the same rich metadata that we provide for the display-only driver, along with the mouse cursor data. And the difference here now is that as it passes this data to the application, the difference here is that this data is actually on the GPU memory. And the reason for this is that the Windows desktop is being rendered by the GPU. So all this data is already in the GPU, and we're just providing it in the GPU to the application. So what that means now is that you can use the power of the GPU to optimize, to process this data before you send it out across the wire or whatever your application chooses to do. And so you can completely hardware accelerate all of this metadata. Now, if you choose not to, that's totally fine. You can move it off to the system memory. You might have already optimized algorithms to deal with it on the CPU, and that's fine. It's just one operation. But since the data was already on the GPU, we thought it best to leave it there for you to utilize. So that kind of wraps up all the features that we are bringing as part of WDDM and the extensions of WDDM. And what I want to do is kind of have a quick recap to call out how you're moving to a single driver model, what is the scenario, and how you can take advantage of these features. So as I mentioned, if you're currently shipping a system with a WDDM driver on Windows Vista or Windows 7, there is no change for you. You can continue shipping that driver. And there are some incremental changes for the driver model in Windows 8, and you just have to work through those. If you're currently shipping a system that is running on the VGA driver, the default driver in Windows 7 and Windows Vista, then again, there is no real change for you. The basic display driver covers all the scenarios and more that were covered by the VGA driver. So the ask more is just to do like a compatibility test pass, make sure that all of your line of business applications, all of your scenarios work just fine, and any of the new scenarios that are enabled either work fine or you just don't support them. That's up to you. If you're currently shipping a server with XDDM hardware, physical hardware on the system, then you need to work on getting a WDDM display-only driver. And again, as I mentioned earlier, it's a fairly simple driver model. We have an entire chalk talk where we can go into more details on how you can make this transition. We can get into the interfaces, etc., during that talk. Also, this driver model can support some of the value-added features that the vendors provide, like the baseboard management control, etc. The driver model is capable of supporting that just the way XDDM did. It's something that the vendors provide value by, and this supports it as well. If you're currently shipping a virtualized XDDM hardware, then again the path is the same. You work with the ISV, and it's the same driver that you would run on your hardware. The only difference is instead of scanning it out over a wire, you might bundle it up and set it out across the wire. And last is if you're using a mirror driver or screen scraper for this remote scenario, then we'd encourage you to use the desktop duplication API because it's really tuned for these scenarios. Your existing application will work on Windows. We have provided backward compatibility, so your mirror drivers will continue to work on Windows 8. But really, the best optimized user experience is going to be with the desktop duplication API. So as a recap to the session, what did we talk about today? We really talked about how WDDM enables the Metro style experience and applications for all the users of Windows, whether you have a WDDM hardware or XDDM hardware. In either case, WDDM is the driver model for Windows. In Windows 8, we've evolved WDDM for very server-specific scenarios, and we've really taken a lot of care to remove some big hurdles and some small hurdles for using WDDM on the server. Moving from XDDM to WDDM is fairly simple. For a render-only driver, as I said, literally it's a matter of a couple of days. For the display-only driver, again, it's not very challenging. We can talk a little bit more about it during the chalk talk later on. And lastly, for high-performance computing, definitely we've got some features there that'll make high-performance computing a lot easier to utilize the GPU and to manage the different GPUs on the system. And so, as I mentioned, there's a bunch of related sessions that are going on here. In this very room, we have a couple of talks right after my talk about the new remote desktop experience. So Gaurav demoed some of these capabilities during the server keynote yesterday by Mike Neal. And so he's going to talk, him and Nadeem are going to talk a little bit more about the remote desktop session experience. And after that, we have another talk in this very room for designing the thin clients and using the remote FX. So that's in this room itself, so you can just camp out here. Now the cool part is, I talked a lot about these new driver types, etc. And you all received the WDK from the Bitbar yesterday or day before. Now, there are sample drivers in there. There's a sample display-only driver, and this driver can be downloaded, compiled, and it actually runs on whatever machine you have. Like you might have a laptop or you might have a desktop which has a BIOS or UEFI, and it's just going to run on that. So what that does is it really sets you off on the right path to start from there and then add in the additional capabilities that you have to offer. And similarly for the desktop duplication APIs, we have a sample in the SDK. This is a DirectX-based sample, and it gets you started off. It just takes, you can compile the sample, run it, and it shows you how to just duplicate the contents of a screen. We did not add any networking capability there because this is a graphics-based sample. So it just takes the contents of a screen and just shows them on the same screen itself. So it creates a cool effect, but better to do it on a multi-mon so you don't get like dizzy. And so again, that's available on the SDK right now. You should already have it. We also published the WDM 1.2 white paper that's going to be on MSDN. And this is an alias we have, the DirectX DX Build QA. If you have any further questions, there's a lot of opportunities. Me and my colleagues are going to be here up front at the end of this talk, and we'll be happy to answer any questions. We have an entire chalk talk at 2:30 p.m. today, and we'll be happy to answer more questions there as well. So thank you.